What if I told you that something we take for granted, the changing of the seasons, might not work the way we've all been taught? Today, we're diving into a source that offers up a pretty radical new theory for what drives our planet's climate, and it challenges some of the most basic ideas in meteorology. All right, so here's how we're going to break this down. First, we'll look at a puzzle about Earth's orbit that seems to fly in the face of common sense. Then, we'll quickly cover the standard explanation you learned in school. After that, we'll get into the source's critique and its alternative theory, which is all about cosmic charge. Finally, we'll see if this new idea actually solves the puzzles it brings up and what it could mean for the whole universe. Okay, so let's jump right in with a fact about Earth's trip around the sun that honestly just doesn't seem to make any sense at first glance. This is the big, central question our source material poses. I mean, your intuition, my intuition, it tells us that the closer you are to a fire, the warmer you feel, right? But for our planet as a whole, it seems to be the exact opposite. So check this out. At perihelion, which happens in January, Earth is about 3 million miles closer to the sun. And yet, the planet's average global temperature is actually cooler. But then, in July, at aphelion, when we're at our farthest points, the planet as a whole is a little bit warmer. According to this source, this is a major problem that the standard model doesn't really have a good answer for. So, what's the official story? How does mainstream science explain why we have seasons? Let's just do a quick refresher on the model we all know, the textbook answer, right? It all comes down to Earth's 23.5-degree tilt. Whichever hemisphere is tilted toward the sun gets more direct, concentrated sunlight, and boom, that's summer. The elliptical shape of our orbit, that's seen as a secondary thing. It might tweak the temperatures a little bit, but it's not the main show. Okay, but this is exactly where our source material starts to poke holes in the story. The author claims this standard model just leaves too many big questions unanswered, and that it's even got some logical flaws. And to really get where the author is coming from, you just have to hear this quote. They're basically saying that they believe the mainstream explanation isn't just missing a piece or two, it's actually illogical, and that we need a whole new way of looking at the data. And this brings us to another huge puzzle the author raises. If the Earth's tilt is the main thing driving the seasons, why is there such a massive, consistent temperature difference between the North and South poles? And we're not talking about a small difference here. It's staggering. The North Pole averages around -30°C, but the South Pole? It's a full 20 degrees colder, averaging a brutal -50. The source argues that this huge year-in, year-out gap is something the standard theories just can't explain. So the author goes through the usual explanations one by one and basically says, nope, doesn't work. Axial tilt? That's constant. It can't explain a difference in the yearly average temperature. Our orbit? Sure, it might make the southern seasons more extreme, hotter hots, colder colds, but it shouldn't change the average so dramatically. And the land versus water argument, the author claims this actually works backwards. The giant landmass of Antarctica should theoretically absorb more heat and make it warmer than the Arctic, not cold. So, if the author is throwing out the standard model, what's the replacement? This is where things get really interesting. We're getting to the core of this whole thing, an alternative theory based on charge. The author calls it the charge recycling theory. And the basic idea is this: the Earth isn't just a passive rock getting heated from the outside by the sun. No. In this model, the Earth is an active engine. It's part of a huge cosmic electrical circuit, pulling in charge at the poles, generating its own heat on the inside, and then releasing it. So how is this supposed to work? Here's the 4-step process the author lays out. 1. The sun shoots out a field of charged particles. 2. The Earth's poles act like big intake vents. And here's where the theory gets specific. The South Pole supposedly pulls in particles the author calls photons, while the North Pole pulls in antiphotons. 3. Deep inside the Earth, these opposite particles meet up, interact, and generate a ton of internal heat. And finally, 4, that heat radiates back out, mostly from around the Earth's equator. All right, so we've got this new, kind of wild theory on the table. But does it actually explain the puzzles we started with? Let's see if it can answer the questions the standard model supposedly can't. Okay, first, let's go back to that super cold South Pole. According to this theory, the extreme cold isn't a problem to be solved, it's actually a key feature. The model says that the point where a planet pulls in the most charge is supposed to be its coldest spot. So since the South Pole is the main intake valve, of course it's the coldest place on Earth. It's proof the system is working. So what about those huge, frigid continents like Russia and Canada? Well, this framework suggests something interesting. Think of the Earth generating heat from its core. The theory goes that the thick, dense rock of the continents actually blocks that internal heat from escaping. Down at the equator, the sun is so strong it doesn't matter, but way up north, where the sun is weak, that blocking effect wins out, making the land much colder than the oceans around it. Now, the author doesn't just stop at Earth. To back this all up, they say, hey, if this is a real fundamental process, we should be able to see it happening on other planets too. For instance, they point to Mars. Its south pole also happens to point toward the sun when Mars is closest to it, which the author interprets as the planet trying to suck in as much charge as it can. And even more wild is Mercury. We've found ice at its poles. How is that even possible on a planet that's basically a baked rock? Well, in this model, it's because that same charge intake mechanism creates a cold spot so powerful it literally stops the scorching heat from the equator from reaching the poles. Okay, so let's zoom all the way out, because according to this source, this isn't just a theory about weather or planets. No, it's presented as something much, much bigger. And get this, the author actually runs the numbers. They calculate that this internal charge engine is responsible for a whopping 44% of the Earth's total heat. Think about that. If that's true, it would mean this internal force is nearly as powerful as all the radiation we get directly from the sun. And this is the final mind-bending takeaway from the source. This whole charge recycling thing, it's not just for planets. The author argues it's a fundamental principle of the universe, a mechanism that works at every single scale, from the tiniest proton all the way up to the sun and even the galaxy itself. And that leaves us with the really provocative question at the heart of this source material. By challenging something as basic as the seasons, the author is really asking us to wonder, could our world, our climate, and maybe even our entire universe be shaped by these vast, invisible forces that we are only just beginning to imagine?